Okay, let's now look at ammonium phosphate. So in South Africa, we're quite lucky because we've actually got a phosphate mine in Phalaborwa, that giant hole in the ground. They use it primarily to mine copper, but in actual fact, it's actually a massive phosphate ore body. And so they mine fluorapatite there. It's actually a very rare geological formation, that mine by Phalaborwa, but I must not waffle on about things that are not related to chemistry. So ammonium phosphate, you have to normally make it out of phosphate rock. Obviously the ammonium is coming from the Haber process, and then we need to get the phosphate from the phosphate rock. Okay, this is what fluorapatite looks like, two of the different kinds of it. So the problem is when you mine the rock, that phosphate is not soluble. Okay, it's a calcium phosphate, and plants can only use soluble phosphates, so you need it to be a soluble salt. So all ammonium salts are soluble, so as a result ammonium phosphate can be used as a fertilizer, whereas you can't just grind up the rock from Phalaborwa and chuck it on your lawn and think something's going to happen. So you have to first use sulfuric acid and then ammonia. So now I've never seen them ask all of these random formulas, but just so you know. So this will be your phosphate that you dig out of the ground. Can you see there's also some fluorine in here, but it's mostly a calcium phosphate. Then you mix it with sulfuric acid, concentrated, and water, and you get this fellow here. Do you remember this fellow? Phosphoric acid. Do you remember acids and bases from last year? A polyprotic acid, phosphoric acid. Where else do we find phosphoric acid? In your Coca-Cola. Okay, let's go back to the reaction. So this rock plus the sulfuric acid and water gives you phosphoric acid, and then this hydrated calcium sulfate. You can see this is a solid, so it's precipitated out, and then this lovely hydrogen fluoride in aqueous solution. So this must be acidic, so this looks like a pretty nasty reaction, because you're producing calcium sulfate solid and then two acids. So I think this is fairly needs a fairly good reaction vessel. So remember now that phosphoric acid is a polyprotic acid. Here's the phosphorus atom, and here are your 4 oxygen atoms. So this is the PO4, and there are these little hydrogens on the end. So you can lose hydrogens along the way, okay? So for instance, here's a stable phosphoric acid. Here's hydrogen phosphate, where there's only one hydrogen, and you can check this is an ion. It's got a 2- charge. Here is dihydrogen phosphate, when you've only lost one of the hydrogens. So we actually go 1, 2, 3, 4. And here's the phosphate ion by itself, which has got a 3- charge. Why are we discussing this? We are discussing this because you get different kinds of phosphate fertilizers depending on how much phosphate it provides to your plants. And it makes use of the fact that phosphoric acid is a polyprotic acid by using each of these sub-steps in the thing to make the fertilizer. So you get the first one, monoammonium phosphate, or MAP. So you mix the ammonia and the phosphoric acid, and here you can see one of these. Remember, go back here, look at my phosphoric acid. 1, 2, 3 hydrogens on the end, H3PO4. Now come here and have a look here. Here's the 1, 2, 3. Okay, if we take one of these off and we transfer it to ammonia, you get the ammonium ion. This one's the ammonium ion. So this ammonium ion goes with this phosphoric acid that has lost one hydrogen. It swaps the hydrogen over here, and you get this monoammonium phosphate. So there's one ammonium ion to this H2PO4 ion. Then you get diammonium phosphate, where you mix 2 ammonias with the phosphoric acid. So 2 of these hydrogens pop off and go and bond, form a dative covalent bond with the ammonia. Remember those dative covalent bonds, people? So you then end up with 2 ammonium ions and then this HPO4 complex ion. So you can see here's the PO4H, HPO4, this complex ion. But you can see now there's 2 ammoniums. So then if you put this on your lawn, you're going to get twice as much nitrogen per phosphate on your lawn as you do with the monoammonium phosphate. Then, just to make it more interesting, you end up with superphosphate and triplesuperphosphate. So that's when you can mix phosphate and calcium sulfate. Okay, so the phosphate and the calcium sulfate, and then you get superphosphate. So when you do this, you still use that phosphate rock like they mine in Palabora, but you put in a different amount of sulfuric acid, and then the reaction doesn't quite go to the same stage as previously. Okay, so you get this fluorapatite. Here's my fluorapatite. Clearly this fluor relates to this fluorine here. And so when you want to make superphosphate, you put in a different amount of sulfuric acid and water, and you end up with calcium sulfate, and then this really weird thing here. Remember that when we did it the other time, you ended up with phosphoric acid. So now instead of phosphoric acid, you get this calcium, which is bonded to this thing that's almost but not quite phosphoric acid because it's missing one of the hydrogens. So this precipitates out, okay, with the calcium sulfate. And then this is this other randomly weird fertilizer. You can also make triple superphosphate, soluble triple superphosphate, and you take the same rock, but now you mix it with phosphoric acid. Okay, remember the other one mixed it with sulfuric acid, but now you're taking the rock and mixing it with some phosphoric acid that you probably made from the same rock, and then you get this weird chemical formula here and the hydrogen fluoride. So now this one is really nice if you need a lot of phosphate for whatever you're growing, because there's no calcium sulfate byproduct. Okay, remember you ended up with calcium sulfate in the other one because you added sulfuric acid, which provided the sulfate ion. Now you're just mixing a phosphate with phosphoric acid, and you end up with super triple superphosphate. Okay, because there's 3 times as much phosphate as there would be otherwise. So then this is good if you want high phosphate fertilizer. Okay, and now I'm just going to add the potassium fertilizers onto this because they don't need their own section because they're really easy. Like I said, this triple superphosphate, I think maybe you need to recognize the formula, but I don't think they ever going to. I hope you can't hear my dog howling. Please excuse my dog howling. Okay, so if you make super triple phosphate, I don't think they want you to recognize this. They might ask you to recognize this and know that this is a phosphate fertilizer, but I really don't think they ask you these reactions. I think that would be really mean. So I would have to go through the fertilizer questions and check again, but spend more time with the contact process. Okay, so the last thing that we use in fertilizer is potassium. So we know potassium because we know potassium hydroxide. You know sodium hydroxide and potassium hydroxide. So potassium hydroxide, or potash, or caustic potash, this has been known since ancient times because overseas there's a lot of old seawater deposits that's full of potassium salts. We don't really have many in this country. I think we have to import it. So once you've got the potassium salts are soluble. So you can have potassium nitrate, potassium sulfate, and this dude here that I don't know his name of it, but they will all give potassium to your plants that you're growing. So we import all of our potassium salts from other countries where there were once oceans covering the land. So Canada, Russia, Belarus, Germany, Israel, and Jordan are all major producers of potassium salts because especially Canada was once under a lot of water. And that's where we are at the end of this fertilizer manufacture. See, I told you the potassium salts were easy. Congratulations if you're still with me.